Welcome to the deep dive. Today we're tackling Monad blockchain.
Yeah, Monad.
And since you're tuning in, you probably have a pretty solid grasp on, blockchain tech generally,
Yeah.
maybe the Ethereum world specifically.
Right.
Think of Monad as, well, potentially a really significant leap forward in that layer one space,
Yeah,
especially if you're an EVM developer.
definitely. And our goal here in this deep dive is to kind of move past the buzzwords.
Yep.
We really want to break down how Monad actually works.
Mhm.
We want to build your understanding, maybe starting with a high-level picture and then digging into the specific architecture, how it fits into the whole ecosystem.
Yeah, focusing squarely on the technical how, like the actual mechanics driving it. We're not really getting into token stuff or airdrops today.
Exactly. It's about the engineering.
So to do this, we've sifted through the sources, detailed articles on the architecture, expert chats, comparing it with Ethereum, Solana, BNB Chain, Avalanche, all the usual
There was
suspects.
some early technical docs, too.
Okay, so let's get into it. When we
Yeah.
talk about how blockchains process transactions, maybe a good analogy to start with is thinking about like a kitchen.
Yeah, a busy kitchen.
Yeah.
Okay, so imagine a traditional blockchain, like early Ethereum, maybe? Think of that as a kitchen with just one really talented chef,
Okay.
but just one. So this chef has to take every single order, prepare every single part of the meal, one after the other, appetizer, then main, then dessert.
Sequentially.
Right. And if the restaurant gets slammed.
Exactly.
Yeah.
That single chef model, it just creates bottlenecks,
Oh.
big delays.
Okay, makes sense. Now, picture like a more modern setup.
Right.
Multiple chefs, right? Each
Right.
one has a specialty.
Mm.
One's on apps, another's doing the main courses. A third's got desserts covered. They're all working at the same time, in parallel.
Right, like parallel processing. It's like your computer, right? A single core processor is that solo chef just chugging through tasks one by one.
Yeah.
But a multi-core processor, that's the team, the parallel kitchen, handling lots of things at once. And that's sort of the core idea behind Monad blockchain, this parallel approach.
Precisely. It's built around this principle. It's an EVM-compatible layer 1, and it's specifically designed to tackle that classic scalability challenge. Trying to get high performance without ditching decentralization or security.
And they're making some pretty bold claims. We're hearing things like 10,000 transactions per second,
Yep, up to 10 kps.
block times like 500 milliseconds, and finality in just 1 second.
That's the target. Plus, full EVM compatibility, which is huge for developers.
Right. And near zero fees, supposedly, and this is interesting, relatively low hardware costs to run a node.
Yeah, all positioned as, direct answers to the limitations we see elsewhere, like Ethereum's lower speed and sometimes painful gas fees.
Okay. And the team behind it, Monad Labs.
Yeah, you've got Keone Han as CEO, James Hunsaker, CTO, and Eunice Giarda, COO. They come from backgrounds in like low latency programming, high frequency trading systems, distributed systems.
So serious engineering chops, people who understand performance.
Seems that way. It provides a strong foundation for, well, building something this ambitious.
All right, so that's the high-level view, the parallel kitchen. Now, for you, the developer listening, wanting to get under the hood,
Mhm.
let's dive into those architectural innovations. How do they actually get this kind of performance? Where do we start?
Let's start right at the base, the consensus mechanism. They call it Monad BFT.
Monad BFT.
Yeah.
Okay. This is how all the computers, the nodes, agree on what the blockchain looks like, right?
Exactly. It's the agreement protocol.
And we know it's based on hot stuff, though these exact details aren't public yet, are they?
No, the specifics of Monad BFT itself are proprietary, it seems. But yeah, built on hot stuff.
So for someone who knows consensus protocols, why build on hot stuff? What's significant there?
Well, hot stuff is pretty well respected. It's known for being leader-based and having strong finality guarantees. So starting there suggests they're serious about network security and robustness.
Okay.
But the key improvement they talk about with Monad BFT is cutting down the communication rounds needed to finalize a block. Yeah, think of it like steps in the agreement. Many traditional BFT algorithms need like 3 rounds of messages back and forth between the nodes validating stuff.
Okay.
Monad BFT apparently cuts this down to just 2 rounds.
So fewer steps means faster agreement.
Directly translates to faster block creation. Yeah, more efficient consensus.
Okay, so faster agreement on the next block. That makes sense. But the really big speed boost probably comes from how they handle the transactions inside the block, doesn't it? This parallel execution thing.
Exactly. That's where the kitchen analogy really comes into play. So traditional EVM, like Ethereum, processes transactions one by one, sequentially.
Right, the single chef model.
Monad uses what they call an optimistic parallel execution model.
Optimistic.
Yeah. Basically, it takes all the transactions for the next block and just runs them all at the same time, concurrently, independently, as if they don't affect each other.
Okay, wait. Optimistic sounds risky. What if one transaction needs the result from another one? How does it handle dependencies if they're all running wild at once?
Good question. That's obviously crucial for keeping the data correct. So the system actually tracks the dependencies between transactions.
Okay.
If transaction B depends on data that might have been changed by transaction A running alongside it, the system spots this. Once A finishes and the correct data is known, it automatically re-executes transaction B using that fresh, updated data.
Ah, I see. So it runs them all fast, assumes the best, but then double checks and reruns anything that had a dependency conflict.
Exactly. That re-execution step ensures the final blockchain state is correct, reflecting the right order and outcomes, even though they were initially processed in parallel.
Okay, that re-execution mechanism sounds key. But I heard that one of the really unique things about Monad, maybe even compared to other parallel chains like Solana, is how they handled the data storage itself. Parallel storage, or MonadDB.
Yes, MonadDB. This is arguably one of the biggest architectural differences. You're right, other chains might have parallel processing, but Monad seems to have pushed parallelism right down into the storage layer, the foundation.
So not just the number crunching, but how the data itself is read and written is parallel too, designed from scratch.
That's the claim. MonadDB is a custom-built database, a parallel blockchain data structure. They apparently built it from the ground up, specifically optimized to store Ethereum's data structures, the Merkle trees, efficiently on disk.
Okay.
And the key is enabling super fast parallel reads and writes, because that's essential if you actually want to benefit from parallel execution.
Right, because any developer knows you can make the computation fast, but if you're stuck waiting to read or write data one piece at a time...
You hit a bottleneck.
Yeah.
Exactly. In sequential EVM chains, state access reading from and writing to storage is often the main bottleneck. Just making the execution parallel doesn't help much if the data access is still serial. MonadDB aims to fix that by allowing parallel state access.
Wow, okay. A parallel database just for blockchain state. That's pretty deep. So we have faster agreement with MonadBFT, faster processing with parallel execution, faster data access with MonadDB. Is there another piece to this performance puzzle? Something about...
Asynchronous execution.
Yes, that's the final key component, really. Asynchronous execution. It basically means separating two critical jobs, consensus and execution.
Separating them? How?
Think of them operating in completely separate swim lanes.
Swim lanes, okay. From a developer angle, what does that separation actually do?
Well, in many, let's say, more traditional designs, reaching consensus on a block and then executing the transactions in that block are kind of mixed together or interleaved.
Right.
And the consensus part itself can chew up a fair bit of the block time.
Okay.
Monad's asynchronous approach decouples them. So consensus happens, a block is agreed upon. Then the entire next block time interval can be dedicated purely to executing the transactions from that agreed upon block.
Ah, so instead of consensus eating into the computation time budget, the execution engine gets the full slot. The whole block time is available for processing transactions.
That sounds like it could massively increase how much work gets done to block.
Precisely. It maximizes the execution budget, allowing for way more computation within each block compared to those interleaved models where consensus overhead takes a big slice of the time.
Okay, wow. So let me try and recap Monad's core tech for the devs listening. You've got MonadBFT for faster, two-round consensus, then optimistic parallel execution for running transactions concurrently with re-execution for dependencies. Underneath that, MonadDB, this custom parallel database tackling the state access bottleneck. And finally, asynchronous execution, separating consensus and processing to give execution the full time slot.
That's a great summary. It's a pretty comprehensive set of optimizations all working together.
It really sounds like it. So with all that technical firepower, how does Monad actually stack up in the real world, in the broader blockchain ecosystem? Let's talk advantages, maybe trade-offs, performance first.
Right, performance. So Monad is claiming that peak of around 10,000 TPS.
Okay. And just for context.
Well, Ethereum today is doing, what, 15 to 30 PPS, maybe?
Yeah, roughly.
Other EVM chains, BNB chain might hit 60 to 100 TPS. Avalanche claims up to maybe 4,500 TPS.
Okay.
And then you have Solana, which often gets quoted with much higher numbers, potentially tens of thousands, like 65,000 sometimes cited. though real-world throughput can vary a lot.
So Monad's aiming way higher than current EVM chains, but still maybe technically below Solana's theoretical peak?
Use that way on paper, yeah.
Are there reasons for that? Like, what trade-offs might Solana be making to hit those higher numbers?
Well, the big discussion around Solana often involves decentralization. Historically, running a Solana validator needed pretty beefy hardware,
Right, expensive machines.
which some argue could lead to fewer people being able to run nodes, potentially making the network more centralized over time. That's one potential trade-off for raw speed. And also, EVM compatibility. Solana isn't natively EVM compatible like Monad, BNB, or Avalanche aim to be. You need layers like Neon EVM, which adds complexity.
Gotcha. So Monad seems to be shooting for that middle ground, like significantly faster than current EVM chains, but trying not to sacrifice decentralization or that native EVM feel.
That appears to be the goal, yes. Balancing performance with those other core tenets.
Okay, so on scalability then, Monad's parallel architecture, that's the key driver compared to, say, Ethereum's sequential model.
Absolutely. The parallel execution plus the parallel state access from MonadDB, that combination is designed to let it handle much more activity concurrently. It scales by processing more things at once rather than just making each individual step faster on a sequential path. It's a base layer scaling approach.
Okay. And then decentralization. You mentioned Solana's hardware needs. Monad claims they can hit high performance and stay decentralized. How?
Their main argument seems to be optimizing the software stack so that running a full node doesn't require crazy expensive hardware. They've mentioned targets like 32 gigs of RAM, a 2 TB SSD, decent internet, 100 megabits per second, and a relatively standard CPU.
Stuff you could maybe get in a high-end laptop or a reasonable desktop, not like a dedicated data center rack.
Yeah, someone even used the analogy a laptop you could get at Costco, though maybe a high-end one. The point is accessibility. And they're initially targeting maybe 200, 300 consensus nodes?
And why is keeping those hardware specs low so critical for decentralization?
Because it lowers the barrier to entry. More people, more organizations globally can afford to run a node if the hardware isn't prohibitively expensive.
Right.
A wider distribution of nodes makes the network more resilient, harder to censor, harder to control by a small group. If only huge players can afford the hardware, you risk centralization.
Yeah, that raises the whole debate about what a full node even means, right? Is it just validating, or is it being able to independently check everything, all the history, all the state, on reasonable hardware?
Exactly. That ability for diverse participants to fully verify the chain themselves is seen by many as fundamental to decentralization. Different projects balance this differently, but Monad's clearly betting on software optimization to keep hardware accessible.
Okay. Shifting gears slightly back to the developer experience, that full EVM compatibility. How big a deal is that?
It's potentially huge. Monad is aiming for complete bytecode level compatibility. Meaning, if you wrote a smart contract in Solidity for Ethereum, you should, in theory, be able to take that compiled code, the bytecode, and just deploy it on Monad. No code changes needed.
Wow, okay, like BNB Chain or Avalanche.
Exactly. That level of compatibility, it's a much lower friction path compared to, say, Solana, where you need specific tooling or compatibility layers.
So for a dev team already building on Ethereum, moving to Monad could be relatively painless.
That's the promise. Minimal learning curve for deployment. And just as important, they're also aiming for full compatibility with the standard Ethereum RPC interface.
RPC. So how nodes talk to wallets and tools?
Precisely. It means all the existing Ethereum tools you use, MetaMask, Hardhat, Truffle, Etherscan-like explorers, should just work with Monad without needing major modifications.
Okay, that's massive. Reduces the friction for developers and dApps dramatically, using tools they already know.
Absolutely. It could really accelerate adoption if they deliver on that.
All right. And the last piece, cost. Transaction fees, gas.
They're aiming for near zero gas fees. So think more like Solana in terms of transaction costs.
Which is a world away from Ethereum, especially during busy times.
Oh, yeah. Ethereum gas fees can fluctuate wildly and get really high, making certain applications just economically unviable for many users.
So near zero fees plus high speed. That could unlock different kinds of dApps, right? Things that need lots of small, cheap transactions.
Definitely. High-frequency trading on DEXs, micropayments, blockchain games where every action isn't costing you noticeable money. It removes a huge economic barrier.
Okay, so wrapping this deep dive up, it really feels like Monad's core mission is to deliver that that holy grail almost. High-speed full EVM compatibility, but without ditching decentralization, using clever software and database design to keep hardware needs reasonable.
That sums it up really well. And it's crucial, especially for you developers listening, to remember this is still very much in development.
Right, not live yet.
They have an internal testnet running, working towards a public mainnet launch. Timelines in crypto are always, well, fluid.
Yeah. Groundhog Day, as the CEO apparently called it once.
But yeah, indications point towards maybe end of this year, early next year for mainnet, something like that.
Definitely one for EVM folks to keep a close eye on that. Okay, so for you, our listener who's stuck with us through the tech, here's a final thought to chew on. As we see these different approaches to scaling emerge, will these kinds of architectural innovations, parallel execution, these bespoke parallel databases like MonadDB, asynchronous processing, will they be the key to unlocking really scalable, user-friendly dApps within that familiar EVM world? Can we actually get that trifecta? High performance, real decentralization, and seamless compatibility that everyone seems to want. It's definitely the big question Monad is trying to answer.
Absolutely. And watching how Monad progresses, seeing if this specific combination of techniques delivers will be fascinating. It really highlights the constant innovation happening to tackle these core blockchain challenges. Understanding these technical trade-offs is, well, essential.
Couldn't agree more. Thanks for joining us for this deep dive into Monad blockchain. We really hope this gave you the technical clarity you were looking for on how it works and where it fits.
Yeah, hopefully that helps you understand the mechanics. We definitely encourage you to check out their resources, follow the testnet progress when it becomes more public, get a feel for it yourself.
And definitely join us again for